Okay, hi everyone. So we'll start in another couple of minutes. I think we're live on YouTube as well. Okay, so let's start now. So, hi everyone. A warm welcome to all of you to this sixth meetup from Mirova Academy. Before this, I already have done five more meetups where in four of them I was the speaker, and in one I invited someone from outside. Okay, so today the meetup is the topic of the meetup is Jenkins pipeline as a code. So we'll be talking about the CI/CD and how to use Jenkins into CI/CD. We'll talk more about the agenda in few minutes. So first of all, I'll welcome all the participants here. We have people from all across the globe. Like we have people from nine different countries right now joining this meetup. So first of all, I request every one of you to introduce yourself so that we all know each other. One of the main purpose of having these meetups is also the like uh, connective, like networking, basically, so that we can maybe help each other in future and learn from each other. Okay, so let us start with the first person I see on the list. Ajmer, can you quickly introduce yourself, please? Maybe your background, your relevant experience into this CI/CD and DevOps, and what uh, made you join this meetup. Ajmer, can you hear us?
Yep, I just muted myself again. Yeah, hi. I'm a DBRE working in London,
Mhm.
and I've been involved in database automation for the last 4 or 5 years, and we're using Jenkins where we are now. So that's what attracted me to this presentation, just to see if there were any tips I can pick up.
Okay, thank you, Ajmer. So please help me because today I'll be only covering the basics part. But yeah, if you can share your experience, that will be helpful. Thank you, Ajmer. Next we have is Alexander. Alexander, can you hear us? Um Looks like he's not available right now, so we'll move on to next one. Amol, can you hear us?
Hey, Sarabhi, I can hear you. So, hey everyone, this is Amol Chandelier. I work as a software engineer in an insurance company located in New York downtown. And my experience with Jenkins is not a whole lot. I used Jenkins for a few months in my previous company, but didn't really understand a whole lot from that. So, just hoping to brush up my skills from this session
Thank
and
you,
learn new
Amol.
things.
Thank you for joining. So next we have is Pankaj. Pankaj, can you hear us?
Yes, sir. Thanks for running this session. And I'm managing actually a team of DevOps engineers in a company in Noida.
Mhm.
And particularly, I'm working right now in the banking domain projects.
Great. Thank you. And the last person on the call we have is Srini. Srini, can you hear us? Srini, can you hear us? If you're speaking, you're on mute right now. Okay, looks like he's not available right now. So thank you for all of you for your introduction. Let me introduce myself. So hi everyone, my name is Saurabh Dhingra, and I'm a test automation and DevOps trainer and consultant working with some of the big MNCs all across the globe as a freelance consultant. Majorly I'm working with Noble Prog, which provides training all across the globe. So I've been associated with seven different countries, like Noble Prog, seven different countries, and I'm also an SME expert at Coursera, where I cover some guided project topics related to DevOps and test automation. Okay. So my experience has been automation all this year. All this experience I have is in automation, whether it's test automation or DevOps automation. So that's about me. Now let's start with the session today. So the idea of all these meetups is to share knowledge. Okay, I'll be inviting a lot of people all across the globe to present these topics. Initially I'm doing it myself so that I build an audience first, and then I can start calling people from other places or other experience. So let's start with the uh, let's start with first understanding what used to happen in traditional way, in traditional software delivery, and how we have moved from there to this new way of software delivery, that is or the deployment, which is CI/CD. And what is CI/CD? We'll talk about CI, we'll talk about CD, and then we'll talk about Jenkins as basics. Okay. So if we go back to traditional way or a traditional approach, okay, I think one of the slide is missing. Okay, no worries. So yeah, let me just uh, go back to the time when we used to deploy the software or we used to develop the software in traditional approach. That's so everything was done in phases, right? First, we have the requirements. We used to discuss all the requirements. After requirements, we used to start coding. So once the requirement are clear, they will be documented in big documents and freezed. After that, development team starts developing it by discussing with the business analysts, right? So a lot of process was or time was taken in the development process. Parallelly, the QA team used to develop the test plan and how they are going to test once the all the product is available in test environments. So everything used to happen in phases: requirement gathering, then development, then QA. After QA, it was given to the operations team, and then it was and then it was actually deployed on the different environments for testing, right? So first we maybe test on test environment, then we test on maybe UAT environment, and then it was delivered to production environment. Now, uh, everything was happening in isolation. So the development team was working in isolation, whereas operation teams was working in isolation. And I remember when I used to work in this approach, I never saw my product getting deployed successfully for the first time. It used to break all the time, right? At least in start, multiple iteration used to happen before we get a running environment. So why this used to happen? Because both the teams were working in isolation, and uh, development team did not consider a lot of things uh, which are required for deployment. Like they were developing, consider their system as the base, but we can have different configuration on the development environments, right? So a lot of uh, gap is there between the development and the operation. Okay, so that's when things started, um, like people started fixing it. So agile came into picture, where fast feedback was required, early delivery was required. So we had to reduce this gap, right? And that's when DevOps came into picture, where development team and operation team started working together, right? A lot of automation came into picture because we had to reduce the time. Okay, reduce the time of building the code, reduce the time of deployment, right? So that's when DevOps came into picture. Okay, so if we talk about some of the challenges, so one of the challenge I remember is that if let's say you have to uh, show any new feature to a customer, okay, it's not possible until everything was deployed in traditional approach. But now if you are working in agile and if somebody wants to see your software, uh, it can be deployed within 2 weeks or 3 weeks, whatever is the duration of your uh, your sprint cycle is, right? If you have some defects in or bugs in the production, okay, that's not easy to fix in the traditional approach. Or even if it was fixed, it was done not with an ideal process. Maybe a lot of patching was done, right? So in this new way of software delivery, that is in DevOps way of software delivery, as soon as you found up any defect on production, you can fix it and deploy it immediately, because everything, all the processes automated, right? So that's what gave birth to CI/CD, that is continuous integration, delivery, and deployment. So this, when we say this word CI/CD, it CD does not only mean one word delivery. You can say software delivery and deployment. So we'll talk about the difference between two, but it's just a very minor difference. So let's first talk about continuous integration. So continuous integration, the purpose of continuous integration is that to keep a check of your code that it is always in running state, right? See, a lot of developers will be working together in a team, collaborating to develop software, right? So if anyone has done some work and checks in the code into their repositories, into the source code management tool, maybe GitHub or somewhere, maybe using Git or any other SVM tool. Uh, Now, as soon as somebody has checked in, this CI, what it do is it confirms that whatever code is checked in, that is in running state. That does not break the existing code. Okay, why we are doing? Because it gives us very immediate feedback. As soon as somebody has checked in the code, we'll get an immediate feedback on that, right? So what continuous integration do? It triggers a build which do a lot of processes. Those processes are, the very first process is it compiles the code. Okay, that is, all the code will be compiled, and if there is any syntax error or any compilation issue, you will immediately get to know about that. And if it is failing, a notification is triggered. Okay, that notification can be an email notification, can be a Slack notification, can be a SMS notification, whatever your team prefers to. But every step will be like a check-in, will be like a gateway. If anything breaks, immediately a notification is sent. So the first part is build. It builds the code, it compiles the code, right? The next step is running unit tests. Okay, so once the compilation pass, we will check that no logic is getting break. Okay, there is no issues in the logic. And how you can confirm that? How can you verify that? By running your unit tests. Okay, once all the unit tests pass, then we do a lot of code matrices and code quality check. Now, what kind of code matrices and code quality check you can do? Like you can calculate what is the code coverage. You can calculate the code smells. You can calculate the number of duplicate code, or how much duplicate code your code has, and so on. Okay. Usually, the first two steps are technology dependent. Not usually, but always these are tech dependent. Like if like you're building a .NET core application, you need the SDK for .NET. If you're building a Java application, you'll be needing SDK of Java or JDK, right? Again, unit test also depends on tech, whether you're whether it's .NET or whether it's Java. So you'll be running the tests accordingly. Similarly, for code matrices calculation, also there are a lot of code available. I mean, lot of tools available. Some of them are tech dependent. Some of them can scan all the different uh, technologies. Like one of the tool which usually is used here is SonarQube. Okay, and the important point to note is that every step here is like a gateway. If something breaks, we'll stop the code to, I mean, we'll stop the build there and then only, and a notification is triggered, right? So this is what continuous integration is. What we get as an outcome of CI is an artifact. What is this artifact? These artifacts are running code. Okay. And it also tells us that our code is in running state all the time. We have no compilation issues. We have no logic issues, or at least the unit tests are not breaking. So as a unit, all the logic is in place, and we calculate the code matrices. There also we put checks that if, let's say, code coverage is above 90%, only then pass the build, otherwise fail it. These criterias are discussed among the team and then are added here. Any questions so far from anyone? Okay, so this is the part of continuous integration. What we get from here is artifacts. These artifacts are running set of code which we can deploy on any environment, and then application runs. Okay. Okay. Moving on to next, we have is continuous delivery. Now, the purpose of continuous delivery is again to give us feedback. See, every step in CI/CD gives us some feedback. Like here, build is giving a feedback that there is no issue at the compilation time. Our code is compiling well. Unit test gives us a feedback that all your logic is running fine. Okay, at least at the unit test level. Then code quality and matrices gives us the feedback on the quality of the code. Okay, but it does not end here. We have to do a lot of other testing, some functional tests and non-functional tests, right? That has to be part of your CD, especially the CD part. Okay, so what we do after we have got the artifact, the same artifact will be deployed on different environments where we perform some different type of testing, and every testing will again give us some feedback. Like we can do smoke test to verify that the artifacts are running, at least loading successfully, or has been deployed successfully. Then we do integration tests to verify, or to which gives us a feedback that our system can integrate well with other systems, right? Similarly, we do feature testing to verify if there is a new feature coming in, whether it's working functionally fine or not, right? We do API testing to verify all the logic of the new feature or the existing feature is working fine. We can do regression tests, right, to make sure that this new feature has not is not breaking anything from the previous builds or previous development. We can do UI tests to verify that functionally UI is working fine. We will do security testing, or will integrate security testing to make sure that at the security level, the build is not breaking. We do the performance testing to make sure that the application we are building works well in terms of performance, right? So all these different set of testing are introduced in continuous delivery. Do we do this practically from the start? No. Practically, when we start deploying or creating the CI/CD, we actually do it step by step. What does it means? We will be the first focus will always be on getting the CI ready, continuous integration ready. Okay. In that also, we first only fix the build. We then fix or add the unit tests. Okay, maybe initially your code quality matrices, the results are not great, so you will not add any checks at the code quality level, but eventually you'll start adding those checks. Okay, Harsimran, you have any questions? There is some background.
Yeah, I was gonna ask, like, so where is the Jenkins in this
Yeah, that
I,
I'll come in to that in another 5 minutes. Okay.
so this is the part which is automated, right?
Yeah, this is the whole
Continuous.
part is automated, and Jenkins is a tool which helps you in automating this process. Okay, so all
The
these
continuous integration is automated, not the delivery part, right? That's two points.
no delivery part is also automated. That is also a part of. I mean, it will be automated through Jenkins only or any other tool. Okay, so everything is
Yeah, it's, but the
every.
testing and all is not is like that has to be
Okay,
outside of
so
Jenkins.
no. Okay, there are two parts. One, you're doing testing separately. You're building tests separately. Okay, but a test is of no use until unless you run it. Okay, so where the execution of those tests happen, that's something which happens as part of CD, that is continuous delivery. So Jenkins is a tool which helps you in running these tests on your environments. Does that make sense?
Um,
Okay, maybe give me 5 minutes, you'll understand. I mean, another
yeah.
5-10 minutes, you'll understand. Okay.
Sure.
Okay, so this whole CI part again, uh, what we are doing, step by step adding the checks, and every check will give you some feedback, right? That's what we have discussed here. Here also we'll do a lot of different testing. Okay, a team which is a mature team or a product is a mature product, you'll see maximum of these steps. Okay, but when we start, maybe we are not there, so we'll go step by step. First, we only introduce integration. Then we introduce maybe the API testing. Then we introduce UI testing. Then we introduce security testing. And then we introduce performance testing. Okay. And the last part of it is that we deploy the same artifact after all these checks to the production. And that is what continuous deployment is. So till this, it's continuous delivery. You're continuously delivering to different environments with different checks, with different feedback. And at the end, you're deploying the same code to production. Okay. So this is what CI/CD is. Now where Jenkins comes into picture. So Jenkins is a tool which can help you automate this whole process. Okay. Jenkins will help you in automatically running the build step. See, if let's say it's a .NET application, then you will be using .NET SDK, right? Or .NET SDK to compile the code, right? It will still be .NET SDK who is going to compile the code, but the process of triggering it or the process of running it as soon as somebody has checked in the code will be triggered by Jenkins. Okay, as soon as somebody checked in the code in Git, a build will be triggered or a message or an event will be sent to Jenkins. Jenkins will look into that or will receive that event and immediately will trigger a build or trigger a process to start compiling the code. First, it will fetch the code and then compile the code. Okay. Once the code is compiled, then based on the results, again Jenkins will take a decision whether to send a notification or whether to start executing the unit test. Again, the unit test will be done or run by the SDK only. Like if it's NUnit, then it will be run by .NET Core. If let's say it's JUnit test, then it will be executed by JDK only, right? But the idea is that the Jenkins is going to trigger these events. Jenkins is going to trigger these points. Similarly, the next step, that code quality matrices check. So it will separately be done by SonarQube or whatever tool you're using there. But the trigger will be done by Jenkins. So Jenkins will tell or will run a process which will start scanning the code. Okay, here you can do static scans, all the static scans for security, for code quality matrices, and so on, right? This gives an artifact. Usually we can hold or store these artifacts in a artifact management tools as well. There are a lot of artifact management tools available in all the clouds. Okay, so you can use any one of them, or you can store them onto the admin machine of your Jenkins also. So that we'll see later. Then once we have the artifact, then again Jenkins will take this artifact and will deploy it on the cloud you're using, the cloud solution you're using. Maybe you're using a cloud solution where you are deploying a code on a virtual machine, or maybe you're using or deploying on a platform as a service based thing. Okay, or maybe you're deploying it as a Docker container, or maybe you're deploying it as a Kubernetes node, right? Whatever uh, process you're following, Jenkins will be the one which is going to deploy it. Okay. Once it is deployed, again another event will be triggered. What that event will do, it will start executing this integration tests which are written. So maybe the tests are written somewhere separately using some tool, maybe Selenium, or maybe um, uh, any other tool, Cypress or Rest Assured or Python tests or whatever. Okay, whatever technology you're using for that, it will trigger a build in a way that it will fetch the code from there, your unit test code, sorry, your integration test code, and start executing them. Okay, so in one line, what if I tell you what is Jenkins? It's a tool which automates the end-to-end flow, which connects all these dots and do it in one single process, do it in one single uh, trigger. Okay. Does this help? Does this explains you, Harsimran Kaur, what exactly I was telling?
Yes, yes.
Okay, great. Any other questions so far? Okay, moving on to as I just have discussed what is Jenkins. Now, if we talk about some of the features of Jenkins, then I've just listed down here. First, the setup. It's very easy to set up. It can be set up on any operating system. I today only I have set up a machine, and it took me hardly 10 minutes to set up everything. Okay, so it's very easy to set up. It's available as like it is available for all your operating system. It is available as a Docker container. It can be hosted as a platform as service. It can be hosted as on infrastructure and so on. Okay, easy upgrade. So as like Jenkins continuously releases new cycles. Okay, every now and then you will find a new version of Jenkins available. So it's very easy to upgrade. You'll just get one single button, I mean one notification. You'll accept that and it will be automatically upgraded. And if things break, you can revert back also very easily. Okay. It's simple and easy to use interface. So I'll say simple and easy now, but when I started with Jenkins, it was not that user friendly. Now it is very user friendly. Okay, and it can also be uh, and you can also integrate with some other interfaces which kind of provides a wrapper over Jenkins and makes it more user friendly, like Blue Ocean is one such interface available. Then one of the reason why Jenkins has become famous is because of the third party plugins which are available. Okay, I don't even know a single technology whose plugin is not available on Jenkins. Whether you're working with Java, .NET, C Sharp, C++, new languages like Python, JavaScript, or maybe Golang, or you name it, you'll find plugins which supports them. Okay, you're working with infrastructure as code tool, Terraform, Ansible. There are plugins available for that. There are more than 400 plugins available out there, okay, which can help you in making your coding in Jenkins easy. Okay, then you can configure the setup environment in the user interface. So Jenkins again gives us a way to code and also a way to manage everything through UI. Okay, so it has a CLI, it has a UI. Okay, CLI if you're an advanced user, UI if you're just starting with it. Then one of the cool feature, or I'll say one of the important feature of Jenkins is that it can work in a master slave architecture. Okay, so I'll just quickly give you an idea why we need a master slave architecture. Say if you're working in a microservice kind of architecture and you have, let's say, different tech stack. Maybe one of your microservices is built in Java, another one is built in .NET Core, third is built in say JavaScript, Node, or you have a different tech stack available. Okay, and you're building a pipeline to support all these microservices. So it's not very simple to install all of these on one single system, right? It's not at all possible. Or why? Because first thing, it becomes heavy. Your server will become heavy. Second, there will be some conflicting tech stack. Maybe some version of a particular application or a library is conflicting with another version. Maybe one of your microservice is needs X version of Node and another one needs Y version of Node. So there can be a lot of conflicts here, right? So to avoid that, what we usually do, we keep our master or an admin on a different server, and then we create different servers or nodes which will have some different tech stack, okay, or SDKs. Maybe we have one node which supports all JavaScript and JavaScript related applications. We have another node which supports all .NET tech stack. We have another one which supports all say JavaScript tech stack, right? So now Jenkins will one the admin one will be the master and the other nodes will act like a slave. Okay, and you can trigger your pipelines or you can trigger your job. If it's JavaScript, you can trigger it on the one which runs the JavaScript one. If it's .NET Core, then you can execute your .NET Core build on the server which is built for .NET Core. Okay, so this is master slave architecture, and if you want to even enhance it, you can create one single server and you can use Docker as different nodes. That is also something which is possible. Okay, so this is what master slave architecture is, and this is again makes it very cool and more scalable, I would say, right? Any questions so far? Ajmer, you have been a good, extensive user of Jenkins. You want to add anything so far? Any of your experiences?
No, I think it's spot on so far.
Okay, great. So if you have anything to add, please help me here. Okay.
Sure.
Next we have is Jenkins is available with test harness built around unit test framework. So basically you can use a lot of testing frameworks to test your things. Okay. Test results are available in graphs and tabular format. So there are a lot of plugins available which makes your test reports in beautiful looking views. You will have graphs to present. You will have tabular reports available. You'll have JUnit type of reports available, because JUnit have been one of the oldest testing framework, I would say. So yeah, that kind of report is there. You can generate HTML report. You can generate some APIs, reporting APIs, so that you can present it on other tools like Power BI. But that's kind of an advanced thing. But yes, you can do that. You can schedule your build execution just like cron execution. Okay, it supports shell and window command execution and notification. So again, Jenkins has a lot of plugins available which provides you a different type of notifications. You can add email notification, SMS notification, Slack notification, Docker, Discord notification, and so on. All these different collaboration tools which you have, you can create notifications for them, okay, using Jenkins. So these are some of the features which I've listed down here. Now, any questions so far? Okay.
Saurabh, I have one question.
Yes, Shreya.
In the previous slide, actually, can I ask? Or?
Yeah, please.
Okay, so in this AI process, so you mentioned like we will get the output as an artifact. So my question is that artifact can be anything like jar file jar file or Docker image, anything?
Yeah, it can be jar file, can be Docker image, depending upon what tech you are compiling here. It depends on that. Yes. So if it's a simple Java application, you'll get a jar. If it's your web application built in Java, you'll get a war file. Maybe if it's C, C++, then you might get some packages. If it's Python, then you'll get code in Python packages. If it's .NET, you'll get .lib files. So it depends on what tech you're compiling, and based on that, you'll get an artifact. If you're, let's say, it's a Node application, but you're creating a Docker image of it, then yes, it will become a Docker image. So artifact is whatever format you need for your application to run is what artifacts are.
Okay, and can we have a, so you mentioned in the CI process we will be having a unit test case. So can we have our Selenium test cases also?
So Selenium we don't use for unit tests. That's part of your smoke test. Okay, could be part of smoke test, could be part of your UI test.
What I meant is like in the CI process, can we have UI test cases or end-to-end test cases just to validate the stability of the build?
Usually it's part of delivery, because I'll tell you the reason for that. See, if you're using Selenium or maybe any such tool which runs your code end to end, okay, then you need to deploy these artifacts first on an environment, right? Here we don't, like, for running the unit test, we only need code. Okay, we need the compiled code. We don't need any environment where we are deploying the artifacts. You're getting the reference? The CI part, we don't need any environment where we have a running application. All the CI part is performed when your application is still in code. Okay, it has been compiled, so you'll have the compiled code, but still only the code. It's not deployed. For performing any test like unit tests, if it's Selenium, you're using Selenium or Cypress, or maybe you're using REST assured or anything, you have to deploy your code somewhere, and then only you can run, because those tests run on your running application, right? And that's why we call it continuous delivery, because you're delivering your code on an environment and then running the test on that. Does this make
because
sense?
I think these unit tests are basically written so that they can run independently of you don't need any user or anything. These are just functions, right? Which just test your
here you are testing everything at the function level, at the coding level itself. You have not deployed the code. Does that answer your question, Shriyansh, or you have anything else to ask?
So one thing, like so after the build process, so once the build process is done, that means the compilation is happening properly. So once the compilation is happening properly, after that, if we have end-to-end test cases like UI test cases, so can't we use that end-to-end test cases also, because the build is completed? That means there is no problem in the project, and if there is no problem in the project, then we can run end-to-end test cases also. This is my understanding.
No, we do that. You're right. We have to do that, but that becomes part of your delivery. Why? Because you need to access application code there, right? You need to access database. You need to access. See, let's say you're building an e-commerce application. Okay, so what is there first? You have that in a code, maybe put in a git repo in GitHub. Okay, you checked out the code using maybe git clone, git checkout, git clone. Let's say you got the code. You first compile it. Okay, so compilation, this build process will tell you there is no issue in the compilation. Done. After that, you run the unit test. See, code is still code only. It's not been deployed anywhere. No test environment has involved here, no QA environment, nothing. So you run unit test. Since unit test executes directly on the code, you can still run this. You scan the code. These are again static scans. So you run it. Then you got artifacts, right? Now this artifact is something which you have to first deploy somewhere on some server maybe your dev environment, maybe your QA environment, maybe your production environment, and then only you will be running your end-to-end test, right? Then only you will be calling maybe a product API to fetch the products. Then maybe you will call another API to add it
I
into
got
the
your
card.
point, Saurabh. Yeah. Now it is clear. Yes. So the thing is like, as of now, we do not have the artifacts ready. So obviously, we will not be able to run our end-to-end test because the application is not up and running.
Yeah. So this CI parts involve these processes. Maybe any or more process you can add, which again runs on or directly on the code. Okay. But the delivery part, yeah.
I was going to say, I think these unit tests are the basic tests for which we have written some scripts, basically to test our code, right? It's not, there's no user involved and all. It's just some scripts we have already written which will test our code.
Exactly. Yeah. True. It does not need any environment to run. It directly runs in your code, calling the functions and so on. Okay. But when you will be running it end to end, or maybe you're automating any flow, for that it has to be deployed in an environment. Now, usually every company, depending upon their budget, depending upon the criticality of the application, they'll have different set of environments. Okay. Usually organization prefer 4 environments. We call them DTAP. But again, based on budget, you can have more, you can have less. Based on criticality of the application, you can have more, you can have less. But usually 4, we call that DTAP. D stands for dev. Usually we do the dev environment, dev testing or integration testing here. T, that is testing. You can also call it QA environment. Usually we do functional tests, feature tests through UI or through API and so on QA environment. Then comes the A, acceptance testing environment, or you can call it staging environment or pre-production environment. That's where that's very similar to your production, and that's why we do security tests and performance tests here. And then last we have production. Production is where we deploy our code and end user uses it. We don't usually do a lot of testing there, but maybe some smoke tests just to make sure that application is deployed and is running successfully. We do smoke test on production. So this is the whole process of CI/CD. Okay, and then we discuss the features of Jenkins. Any questions so far? Okay, now we'll.
Hello. I have a question, please.
Yes.
What is the common tools we use for the CI part?
Okay, so CI here. This first process depends on your technology. If it's .NET, you need .NET SDK. If it's say Java, you need Java SDK. So you can use either the Docker images or the direct installation of that. Unit test again depends on that. For code quality matrices, one of the most used tool in the market is SonarQube. Okay, so SonarQube is one tool where you can use your static code scanning to get the like a report which tells you what is the code coverage, what is the how much code smells you have, how much duplicate code you have. It gives you numbers for each. I don't have any screenshot right now, otherwise I would have shown you. Yeah, so these are some tools used, but to do all this triggering, you can use any CI/CD tool. Jenkins is one of them. Other tools are Azure DevOps, TeamCity, Bamboo. There are a lot of tools available out there in market. Does that answer your question, Matt?
Yes, thank you.
I have a question, sorry, on the same screen.
Yeah.
This unit tests are also done on the slave machine?
Depends on how your whole Jenkins is set up. So if in case let's say you're using master only to administrate, you're not using master for any tech installation or anything, then yes, it will be executed on a slave, either on a Docker image or directly on a slave machine. But if let's say it's a very small project and you're doing everything on admin machine, then you can run on the same machine. So yes, I hope I answer your question.
So what in our basically my area which I work. So they have like a job, like Jenkins job for build, and then they have separate job for deployment, Jenkins job. So between these two, I don't see any this unit test. Where would that happen basically? I see just that we build a Jenkins build job, which we run for the build, and then the application team wants us to run a deployment job.
So I'm not sure about your application, but as soon as the compilation is done, immediately we trigger execution of the test. That I'll show you in one of the example also today.
Okay.
I think Saurabh, what he's mentioned was like I think CI/CD pipeline can be created in multiple ways. So in her Siemens project, what is happening is there is a dependency between the two jobs. But here, what we are discussing is like we are creating the pipeline using the scripting part. Correct?
Okay. So dependency, you mean that one build is successful, then the second build is triggered?
Yes. So for example, one Jenkins job is successfully, then only we will be executing the other job. So basically, we are creating the dependency between the Jenkins jobs.
Okay.
No, it's a build and deployment is just the build basically, and then deployment is after we have the artifacts, right? So
yeah. So maybe that unit test either you might have missed that or in the process, or maybe it's not available in your project. But usually,
I think it might be they must be doing some like Jenkins build should trigger the unit test is what you said basically. So that probably happens, and then they ask us to run the deployment once they see the unit tests are okay.
Yeah, so maybe in another 10 minutes we'll see this whole process, and then that gives you an idea.
Sure.
Okay, now if we talk about the evaluation of Jenkins, okay, so Jenkins became famous very early. Okay, it was the first tool not first tool, but one of the first tools, I would say, or initial tools, not the first tool, but initial tools, which made this CI/CD actually possible, famous, right? And Jenkins also became famous under the process, in this process, basically. So the very first type of deployment was the freestyle. Okay, now what is freestyle? Freestyle is that process where Jenkins tool have all this process we are talking about. Okay, the architecture is something like this. Okay, we have Jenkins. In that, we create a job. In the job, there is a process which will fetch the code from the repository. There will be a process which keeps on checking the source code management tool for changes. There will be a process which will have all the secrets and everything, all the you can say credentials and everything managed. Then there will be a job which will do the building, the testing, the quality matrices, and then there will be a job which will do the publishing and the deployment. So everything is managed in Jenkins. There will be a configuration file, okay, which this whole UI is coming from this configuration file only. Okay, but everything is managed at the Jenkins level. This is what Jenkins freestyle is, which is an older approach. Okay, now what are the challenges you foresee here? Okay, anyone wants to add any challenge? I mean, what do you think? Let's make it interactive. So what do you think could be the challenge when everything is managed at the Jenkins level? Okay, anyone wants to add anything here? Okay. Anyone? Okay, let me add here then. See, when everything is managed at the Jenkins level, not at the code level, then you have two things to manage. One, your code, and second, Jenkins build. Okay. Now think, and that will give you some ideas. So one thing can happen is that if, let's say, you have you're managing your code in X way, and there is one Jenkins job to deploy. Okay, so you're fine with it. Okay, now your code start evolving. You're adding more and more code, more and more feature. Okay, and the way your code compiles and deployed now is different than earlier. Okay, but you will keep updating your Jenkins pipeline as and when your code is evolving. So there is no versioning of your pipeline, right? There is no versioning of your pipeline. So eventually what will happen? You will only have your pipeline which maps to the latest code, right? Now let's say a new client come to you and they want your application in older approach. Okay, maybe they don't want the new features you have developed, they only want the old features. Okay, so now you can, I mean, when you I mean, if let's say you take the checkout of your older code, okay, you can take the code checkout, but there won't be any pipeline for that because your pipeline now has evolved and is mapping to the new one. Another can be, say, there was some issue found in the production and you have to revert back to older approach, or maybe a feature you developed is not working anymore, you have to revert back to older approach. So there is no pipeline available for that. There is no versioning of the pipeline, right? This is one drawback. Second, you have to manage two different things. Third, let's say for some reason your server where this Jenkins build is stored or is deployed, and for some reason that server gets corrupted, it will become difficult to get this whole thing back. You might have to take the server, you might have to take backups of the server, you might have to restore the older version, and there are chances of you losing your build, or there are chances to where you will lose all these progress you have made, right? So these are some of the challenges which were there with the older freestyle approach. And that's when Jenkins did a pivot, because there were a lot of modern day tools which were coming in market, and they introduced something called pipeline as code, right? What we did in pipeline as code, or we can call Jenkins pipeline as code, is now Jenkins is not storing anything at its level. Okay, what it do is it reads a file. Okay, it reads a configuration file which is written in some domain specific language. We call it declarative language or scripted language. So there are two different languages available in Jenkins. One is scripted and one is declarative. You can use a combination of two. You can use only declarative, you can use only scripted. So what we started doing is that we start storing all our pipeline as code in Jenkins file. Okay, and now for everything there is only one single source of truth, and that is your Jenkins file. The code triggers are mentioned in files. The all the secrets, all the configuration is defined in Jenkins file. Your building, the execution and everything is written in Jenkins file. The process to publish and deploy is written in Jenkins file. So there is only one single source of truth for all the execution, all the deployment, right? And this Jenkins file, since it's code, it's a file, it's a physical file, it's a code, you can version it according to your application. Okay, so as in when your application is evolving, you're changing your Jenkins file, but you still have the older version. Okay, there is a one-to-one mapping with each code. Okay, if let's say today your code is compiled in X way, you have a Jenkins file for that. Maybe 6 months down the line, your code now needs a Y process of deployment, you will have another Jenkins file which deployed in Y format, right? So this Jenkins file will still be stored in your repository. Okay, your triggers will be added at the repository level. Okay, but all the code to compile the code, to deploy the code, to build the code, to publish the code, everything is here. Okay, is written in a Jenkins file. Okay, so this is what Jenkins pipeline is. Okay. Jenkins uses a domain specific language. We call it declarative language, or you can use scripted language for that. All other tools also uses the similar format, that you have one single file for configuration. Like if you talk about Azure DevOps use YAML syntax, right? If we talk about GitLab is another powerful CI/CD tool that also uses a YAML syntax for storing your configuration file, which has your pipeline as code. Make sense? Any questions so far? Any doubts? Okay, moving on to next. Some of the benefits of Jenkins pipeline. So as we have just discussed, we'll automatically create a pipeline build process for all the branches and pull requests, code review iteration on the pipeline. So now since your pipeline is also as a code, you can do code reviews for that. Okay, you will have a whole, proper process for managing the different branches. You can have pipeline code go through a complete code review process. Okay, you can audit trail the pipeline. You'll have one single source of truth for your pipeline, okay, which can be viewed and edited by multiple members of the project. Okay, and if for some reason you lost the server where Jenkins is deployed, you don't have to worry, because your pipeline is now as a code. You just need another server with another Jenkins install on it. Maybe few modifications required, but like some plugins are required, but in advanced ways you can actually make that also as scripts. So what I mean is that your Jenkins, the deployment of Jenkins along with the along with the multiple plugins can also be made as scripts, and you can store them. So if let's say your server gone, you just get a new server, deploy that, you'll have a same Jenkins as earlier, and then use this pipeline to deploy the code. Right? So these are some of the benefits of pipeline or pipeline as code. It's not only Jenkins pipeline, but all other tools which use this approach of pipeline as code is something which we just discussed. Any questions? Okay, so all these features we all already discussed.
One question.
Yes, Shriyans.
In the previous slide,
Mm-hmm.
so it says first point creates pipeline build process for all branches.
Mm-hmm.
So at a time, like it will be having only single branch. For example, it can be main branch or feature branch.
So there is a concept in Jenkins called multi-branch process. Okay, what it do is, see, if let's say your developer is checking in some code, okay, maybe you're using a feature branch approach. What does it means? That you have, let's say, master branch, dev branch, feature branch. You're managing multiple branches. Okay, you're using multiple branches to manage code. Maybe a new feature come, you create a new feature, and now you want to keep a track of all these branches, that whatever the code you're adding in that, all of them are in the running state all the time. So there is a feature in Jenkins called multi-branch. What it do is you configure it for multiple branches, and as soon as somebody has checked in the code in X branch, it will trigger a build for compiling the code of X branch. If it's checked in Y branch, it will trigger a build to trigger a process of compiling the Y branch. Does that answer your question?
Yes, thank you.
Yeah, so it's another very useful feature of Jenkins. Not only Jenkins, other tools also has it. But yes, this is one of the cool feature where even for your feature branch, you can manage a different CI. Okay. Now, these are the features of Jenkins pipeline, which we have already discussed. So code, we've already discussed that you can manage your pipeline as code now. It enables DevOps here. Durable. Uh, so pipelines can survive both planned and unplanned restarts of the Jenkins controller because the code is managed as a pipe. I mean, your pipeline is managed as a code, not just as you're not dependent on the server of Jenkins. If something goes wrong with the server, you're still safe. Possible. So your pipelines can optionally stop and wait for human inputs. So there are ways to add manual interventions in between. Okay, versatile. So pipeline supports complex real-world CD requirements, including ability to fork, join, loop, and perform work in parallel. So basically, what it means is since it's now managed as a code, you can add advanced stuff like adding conditions, adding conditional execution, adding loops, adding advanced complex scenarios, and so on. Extensible. The pipeline plugin supports custom extensions to DSL and multiple options for integration with other plugins. So what it means is there are a lot of plugins available which will make the process very easy. Like one line configuration also possible. Okay. Now this is an example, very simple example of a Jenkins file where I've shown different steps. So this is the syntax. This is called DSL. I mean the declarative syntax. It will have a pipeline. The first block will be a pipeline. It starts, curly braces starts. Then you decide the agent. So you can have any agent configure. Every agent will have a name. I'll give you an example for that also. Then starts the stages. Okay, by the way, when you define any, then whatever node is available, it will run on that. If no external node is available, it will run on the same admin machine. Okay, but if an external node is available, it will run on that. Then you have stages. In stages, you can define multiple stage. Like one of the stages checkout, that is you're checking out the code. Okay, then second stage is build, where you're compiling the code. Okay, like let's say it's some Java application and the build management tool is Maven there, then you can run Maven clean, compile, test, package, all these steps. Okay, once all these steps pass, maybe you want to publish a report, so you can use a post step. This only executes when this is done. You can have conditions in here like always run, whether it's pass or fail. You can have run only when it is successful. You can also add steps like when it has failed, then only run. Okay, so under post, see, I'm running JUnit report, like creating a JUnit report always, whether it's pass or fail. Because I need the report no matter whether all my tests pass or all my tests fail, right? Or whether the build pass or not. Right? So based on that, you're generating a report. So I'm always generating a report no matter what is the result of here. Okay. You can also keep it like this. You keep clean, build, compile in a separate step, maybe only in build, and then you add another stage called test, and then do the test, and then put this always. Okay, and only when this is successful, then only I need my artifacts. So I'm archiving the artifacts only when this whole thing is successful. Where in some artifact directory, which we can call target, or you can have some external artifact directories configured here, and so on. Depends on how you are managing your artifacts. So this is one example of a Jenkins file. Okay. Now I have prepared some example. So let me just show you that also. So give me 1 second. I'll just pull out the system where I have, or sorry, the link where I have this installed. Okay, so this is where I have already installed the Jenkins. It's very straightforward to install Jenkins and set up. After that, I'll log in with my credentials. Okay, so this is the UI of your Jenkins. Okay, now uh, here few things you should know. First, manage Jenkins. Any configuration you need at any level, generic level, plugin level, security level, credentials level, everything you'll find here. Okay, so manage plugin is the place where you'll find all your configurations. Okay. Now, you want to configure a system, we have configuration here. You want to manage plugins, here are the configurations. You want to manage the nodes, like when you're running it in a master slave architecture. So you can use this manage nodes to use this. If you're like if you have some security level configuration required, you can handle here. All the credentials are managed here. All the users, like you can have multiple users integrated as a single sign-on, that is also possible. So you can use manage users for that. Okay, so plugin, quickly go to plugin. So if you go to install these, here you will find all the different plugins available. Again, there are a long list of plugins available. Okay, I have installed a couple of them. Like I installed one with name Docker. So if I do Docker, so this is the one which I needed. This is the Docker pipeline. So to create a Docker pipeline, I need this plugin. Okay. Basically, I'm using Docker to create the images. Okay, so this is the only plugin I have installed. Rest all were done at the time of setup. Okay, but let me give you an example what kind of plugins you'll be requiring. So you'll be requiring plugins to perform a Git operation. Okay, so you have Git client click plugin already installed. Okay, you might be requiring a Node plugin to maybe compile the Node code. I mean, code for Node applications. Okay, there is a plugin which generates all these pipelines. So there is a pipeline plugin also available. Okay, so when you're doing initial setup, at that time it asks you whether you want uh, all the preferred plugins or you want to choose. So when you're choosing, make sure you have pipeline, make sure you have the plugins for Git. Okay, you can add more plugins. Say for example, you're using Bitbucket as the code management tool. So you can just search for Bitbucket and install this. These will make your life easy. I mean, you have to do less coding if you're using these plugins. This also has a drawback because sometimes some of the plugins might have some security issue. So make sure your IT knows which all plugins you're installing and they have properly scanned them, gone through them, and have checked that there is nothing which is breaking. Okay, so those are the things which you can do or test first. Yeah, these are the things which you need to take care here. Okay, rest it usually is done by IT team. Okay, then uh, to create or deploy any new application, you can use this new item. Click on new item. Okay, then give the name. Say for example, I want to deploy a sample, say sample Python app. Okay, I'll call it sample Python app. Then you get an option to choose freestyle or pipeline. Okay, right now I'm using pipeline because freestyle is nobody's going to use freestyle anymore. We discussed about the limitation of freestyle and limitation of the uh, why pipelines are better. So choose pipeline. Okay, and we have multi-branch pipeline which Shransh we were discussing. So multi-branch pipeline is the one which you can use for triggering the multiple branches together. Okay, you can create folders, you can create organization folders and so on. So I'll choose pipeline, click OK. Then it presents a form. Okay, this form looks very similar to the freestyle, but is very different. Okay, like you can first define some configurations here, But these configurations can also go in a pipeline. That's the good part. You have some triggers like you want to trigger them regularly on recurring basis. Maybe every 9 o'clock you want to run, every Wednesday you want to trigger some build, every weekday you want to trigger some build, over weekends you want to do a full regression suite test. So those kind of regular triggers can be added here. Okay, and then you can add triggers to you can add triggers which are at uh, uh, which is like defined in your Git repository or your GitHub repositories, just like a webhook. So in your repository, you add a trigger that if someone makes any changes to the code, it should trigger a build. Okay, like that. Those kinds of triggers can be added here. Then we have pipeline. This is where we add our code. Okay, now pipeline can be added here. So if you go here, you can simply click on this. So this is the same example I showed you, right? You have pipeline block, then you have agent, you have stages. In stages, you have different stage. You can keep adding different stages. Okay, you can manage your pipeline here also, but this does not make sense, right? You've made a pipeline as code, but you're still managing it at Jenkins level. So what we usually do, we get the pipeline from SCM, that is source code management tool. Okay, now I have already created one pipeline. Okay, I think let me get that first. One second. Okay, I got the code. So here is a pipeline. This is a sample application, okay, which has some Python code, a Python sample application, very simple application, but a Python application. So we are going to use this Jenkins file to deploy it. Okay, so let me get the this link. Okay, and what I need to do is you select pipeline from SCM, then you select your SCM tool, whether you're using Git or you're using any other tool. Okay, right now only Git is coming because only Git plugin is installed, no other plugin is installed. Okay, that's the reason it only shows Git. So I'll select Git. Then it will ask me the repository. So I'll give my repository. Since my repository is a public repository, it is not asking for credentials. But if you are doing it for your application, I'm pretty sure you're not using public, right? You must be using a private one. Then you need to supply your credentials as well. You can use all the different formats of credentials, username, password, which now nobody supports. So secret file is also there, and so on. Okay, so right now I've just added this. Then specify the branch here. Since it's single, so you have to specify only single branch. Okay, and then you give the script path. Script path is the file which has the script. By default, it will choose the Jenkins file only, but it can has a different name. So if it has a different name, give that different name here. Okay, so right now it has Jenkins file, so I'm here. Now see, pipeline. So pipeline is my first block. Agent, none. I'm not specifying any agent here. Why? Because for every step, we are using a different agent. See, for build step, I'm using an agent, okay, which uses a Python Alpine image. Okay, so this Python 2 Alpine image you can find on Docker Hub. So this is my agent. So basically, I'm creating the agent, okay, as a container at the time of at the time of this execution only. Okay, so this becomes my first step. Sorry, I've defined the agent. Sorry. Then comes the step. So in step, what is this process? Build. So I'll add the process or I'll add the steps to compile the code. Okay. Now to compile the code, I need to run shell script. So this sh is the shell script. Okay. Now, how will you come up with these commands? whether to, I mean, how I got to know that it is Docker command, how I got to know that for running a shell I need sh, how I get to know that to get an image I use this image. For that, in Jenkins, there is this pipeline syntax. Okay, open this. This is kind of a snippet generator. What does it means? Uh, you cannot remember all the steps, right? I cannot remember how to run a shell. I mean, there is no need to remember. Okay, maybe few common things you can remember, but no need to remember everything, right? So this is a snippet generator where whatever you want to do, say for example, I want to run a shell script. I'll select shell. Okay, then I will give the script. Let's say I want to run mvn clean. Okay, I give this. If there is any advanced level of setting you want to do, you can define them here. Like you want to define any label or you want to define any encoding, you do that and then click on generate pipeline script. It will give you the syntax or the code. Now copy this code in here and done. Right? Say for example, I want to do, or I want to use, let's say, credentials. So I can say with credentials. Okay. Then it will ask you what type of credentials you want. Let's say I want a certificate. Okay. Then what kind of certificate or what is the key store, or basically it will ask you for all the other parameters. Pass them, click on generate pipeline, it will generate a block for you. Right. So this is how you can generate the code. Right. And for custom plugins like Docker, okay, for the Docker, for that you have to read its documentation. That's the easiest way. Just go to Docker pipeline plugin, you will see its documentation, you'll get to know what is the commands. Some of the plugins, or I would say most of the plugins, will provide you this snippet generator, but many of them won't. Okay, let me check. Say let me see for the Docker. So if I say Docker, see, there is no direct one available for Docker, right? There's no Docker available. So for that, I have to read the documentation. There is no other way. But most of the cases, you'll find the syntax here. Okay. So with that, let's say here, the first thing I'm doing is build. For that, I'm generating an agent, which is a Docker container. And I told which image I'm using. Second step is test. For that, again, I'm using a new agent, which using this Docker, in which the image I'm using is one which has py test. Okay, because here only I need py test, so I'll use that image. So it will create a container with this, and then you execute the steps to say run the test. Make sense? Any questions so far? Now remember, we saw that for every step you can also add post step. Like I have executed the test, based on the results of execution I want to publish the report. Okay, so post this step, publish the report. Always, whether it is pass or fail or skip, no, it doesn't matter, it will always publish a report. Right? Then the last stage is deliver, where we are basically delivering the code, right, or deploying the code. And post that, we are also archiving the basically we are archiving this artifacts, storing it somewhere for the deployment, right? So basically this is the whole CI part. Okay, now let's run it. So to run, all you need to do is tell the path, script path, where your application will be deployed. Oh, sorry, where your pipeline is there, right? All the pipeline code. So give that script path. Done. Click on save. Okay, and then you need to build. So when you click on build now, it will start triggering the build. See, this is the place where it will show you all the steps along with its progress. So build, test, deliver. Okay, You can check the logs by either clicking on this or click on this and go to console output. This is the most important place because this is the place where you'll find all your um, logs. Okay, if let's say there's something is not working, if any application, any build breaks, maybe something happened, maybe you have some missing plugin, maybe you have some missing uh, let's say you're deploying a .NET application and .NET is not installed. No matter what error is, you'll always find that error here itself. Okay. Yes, there is a question. Any question? Somebody has raised the hand. Jaro Sto.
Yes, I have a question. Do you have an idea about debugging your pipeline? Yes, how we can correct our mistakes?
Debugging.
Everything can happen during the coding of the pipeline. Yes, so maybe you have some kind of idea how we can manage this kind of the situation.
Yeah. So debugging the code, my first preference is always come here, read this logs, check the errors because this pipeline gives you all the errors in detail. Okay, any error you get, you'll find it in detail here. So that is my first step. Okay, now common errors which usually comes is one of the common error you get is node not reachable. So maybe you're using a master slave architecture, your node is not communicating with your say the master machine, so you'll get proper error message here. So I would say for me the best way I debug is always this. Okay, another thing is you can manage your Jenkins file as, I mean, usually we manage our Jenkins file in Visual Studio Code, right? So there is, I remember one plugin I've used. It's Jenkins, yeah, runner. So this is a tool which you can actually use to run your code through Visual Studio. Okay, whatever I'm doing there, you can use this also to run the through Visual Studio, and you can use now the debugging capabilities of your Visual Studio Code. Does that answer your question?
Yeah, thanks a lot.
Yeah.
But we still have I think it's quite difficult part, especially if you have this more complicated version. I think that it's not, I don't know really the perfect solution for this problem. Yes, and I think that it's still waiting for solution. Yes, I think so. Yeah.
Yeah, I agree to you. I have been at. Yes, sorry.
Oh, sorry. You present the declarative pipeline, yes, but if you try to use the scripted pipeline, it's quite complicated situation if you have to find in the back your pipeline, yes. Especially if you use the shared library or something like this, yes, it's
yeah, yes, I do agree with you. One of the things which makes Jenkins pipeline a difficult one is the debugging. That is the most difficult thing. What usually I have done, or what I have done in when I used to work with Jenkins pipeline, is my the go-to solution was always reading the error and then debugging. That's the only way I've find out. And for the basic things I've also used this plugin. It was also helpful, but I do agree to you, it's the most difficult part. Maybe I'll discuss with some advanced user of the advanced people who are using this Jenkins a lot. Maybe if they have come up with some solution, we can discuss later sometimes in some of the meetup. Okay, so this is the pipeline, and then you get the whole pipeline as a solution here. If you'll have your reports, those will, I mean, if you'll have your tests added, those will also be shown in the reports like this. They also creates a beautiful graph when you'll run it multiple times. Okay, let's say you have executed the whole test 10 different times, it will create a proper looking graph. Okay, your artifacts which we archived are actually available here. So when you click on it, you can see I've downloaded an image. I mean, this is a Docker image basically. Okay, I cannot read it, but I'll maybe if I could connect to the system, I could also show you that the Docker images are installed. Yeah. So this was just a very simple example. In real, you'll have more complex pipeline where you'll have a lot more steps added. Few more things which you can learn after this is uh, first thing first thing I would say is learn the whole flow. I mean, adding the build, test, deploy, and other processes. All those we saw. Okay. Then multi-branch is something which you can learn, and then there is one more concept of shared libraries. So shared libraries is where, let's say, in your microservice based architecture, you have 10 different microservices, and the process to or partial process in all each of your microservices same. So what you can do is you can write that once and reuse in your pipeline. Okay, I have some examples. Maybe I'll show quickly. Um, so this is the one example shared library, which very basically um, uh, yeah, in the vars folder it's usually created, and it's created using the groovy syntax only. Okay, so here I have added one single method which checks some prerequisite. Since I need it in all my code, so I've added it here. Similarly, I have another one which has another set of code. I mean, this is same. So let's say, okay, this third one, which again do the common thing, I've added it. And then uh, in your normal pipeline, there is a way you can first call the shared pipeline and then add the rest of the code. Okay, so this is also something which you can learn. Okay, so yeah, this was whole Jenkins pipeline as code. Within this duration, I could cover this much only. Any questions you have, please let me know. Okay, so just since we are ending here, one couple of things, please don't drop before that. First thing, I do conduct these meetups regularly, almost every weekend. Okay, so this is the sixth meetup today. Before this, I've already done 4 meetups. So you will find the recordings on my YouTube channel. So I'll just share the YouTube channel as well. So the recordings will usually are updated in couple of days. Most probably by Monday it will be done. Okay. So I'm sharing it at both the places. Okay. Yeah. Second thing, all these meetups are actually available on whichever group you're part of. Like I'm running 9 different groups, so in different locations. So whichever part of you are, you will get the links to join the other meetups regularly. Okay. And the next meetup is not on the next weekend. I have to go somewhere. So the next meetup is on 12th of March, and I'm going to present Terraform with Azure for absolute beginners. I've already done in one meetup where we did Terraform with AWS. This is the next one where we are going to specifically talk about Terraform with Azure. So if you're interested in this, you'll like whichever group you are part of, you can just go and register there. By tomorrow, it will also be live on LinkedIn. I forget to do that today. So yeah, please enroll there, and please also subscribe to the YouTube channel. We always go live whenever we have these meetups there. So please enroll there as well. And last thing from you all, I have a request. Could you please give the feedback for today's session? Anything you liked about or you did not like about, any suggestions you have for me, any feedback the way I delivered that will help me improve as a trainer and a speaker. So please quickly, can you give a quick feedback? Maybe in written, maybe verbal.
I think I liked everything, Saurabh. So whatever you have presented, your explanation was very clear, and the questions which I have asked, you have responded them very comprehensive in a very comprehensive way.
Thank
So
you.
I liked everything.
Thank you. Thank you. So thank you, Shranch. You have been one of my old person. We are connected. So just one last thing before everyone goes. Anybody else wants to share any other feedback? Let me just get the invite.
I can say good work. Thanks a lot. Yes. And
Thank you. So I've also created this Discord community, which I'll again share the links in the chat. So if you're interested, you can join this Discord community. This is the place where we can discuss the tips and tricks and a lot more about DevOps, test automation, cloud. I'm building this community now. It's just 3 people community right now, but the target for this year is to reach somewhere around 100K. I'm working on the plans. It's going in parallel. We'll be making it live soon. Okay, thank you everyone for your time. Any other feedback from anyone? Thank you, Subin, on LinkedIn. You're live on LinkedIn. Thank you. Any feedback from anyone else? I hope the time was worth spending here.
Absolutely, Saurabh. It was like good. I mean, for the Jenkins part, I didn't expect that much that you'll go into the pipeline code and talk about those things. That was incredible. We'll highly appreciate if in any time future, not immediate or something that I'm thinking of.
Mhm.
But if Cloud and Jenkins can come together at some point of time, that will be a really good experience.
Sure, that's a good idea. I mean, I'll prepare something, or maybe I'll invite someone who can help here. So if you have any topic ideas just like this, you can drop that as well. That is also something I'll try to arrange, because right now I'm more alone doing this all. But if community will help, then I think we can create really good content and topics
Definitely.
here.
I mean, there are two parts to it which I means we as a group will definitely think about. One is the way cloud is a very diverse thing. I mean, cloud is just not about one means one provider. It
Yeah.
varies by the company that it provides. And the second is the technologies of the build. They in their way different. Are very different. I mean, an iOS build cannot have any space on Windows and vice versa. So I will not say vice versa, but still yes. So that part can also be given